Okay, good afternoon, everybody. Uh, Thank you for coming to see my talk about scriptable render pipelines. It is my first time here in Seoul. I'm loving the city so far, so once again, thank you for coming. So, uh, well, okay, I'm done. Okay, thank you, everybody. Uh, anyway, first things first, I am not John Sitzma. Right? If you guys seen the printed schedule in the lobby, John was supposed to do this presentation. Unfortunately, he couldn't join us, but I'll do my best to present as well as he would. So as I said, my name is Jay Santos. I'm Unity's lead evangelist for the South Asia Pacific region. So today, as I said, we're going to talk about scriptable render pipelines, which is one of the most exciting new features coming at Unity 2018.1. So we're going to talk about what is a scriptable render pipeline. I'm going to say from now on, I'm going to try to say SRP for short, instead of scriptable render pipeline, just to make things quicker. And then I'm going to show you a couple of SRPs that Unity had made available for you to start using them and learn about them. And then we're going to go over how you get started using scriptable render pipelines. So first of all, what is an SRP? So not all games are born equal, right? Different games have different needs in terms of rendering, in terms of lighting, shader, performance, whatever. We're going to go over some examples. But what Unity is offering to you with the SRPs is a way for you to customize and configure the way Unity renders your game. So SRP is basically a set of C# hooks that are going to connect to C++ code that enable you to make this customization. So here's an example of the render pipeline, which is essentially the processes that the game objects in your game go through in order to be rendered on the screen, right? As you can see, this is a very, very, very high level view, of course, but as you can see, there are several processes, and into each one of these processes, you have several steps, like, for instance, the forward rendering and defer rendering that you have right on top, right? So what the scriptable render pipelines allow you is to customize this process, right? So for instance, here we have one of the steps is skybox. But maybe your game don't have skyboxes. Why do you need to go through the skybox process if you're not using it in your game? So you can remove it. Or maybe you want to customize the skybox process to make a cartoony skybox, a dreamlike skybox. You can do that too with SRPs. So, as I said, not all games are born equal. Different games have different graphics needs. Let's go over some examples. So the first one is, there you go, I skipped one. So the first one is the realistic first-person shooter for high-end desktops and consoles, right? So the graphics needs of this type of game scream lifelike, high quality. So of course you're going to use global illumination, you're going to heavily use reflection, you're going to heavily use shadows. You will need to use a lot of post-processing effects, which by themselves are very expensive in terms of processing, right? You may want to use photogrammetry. You will probably not use a lot of UI in order to avoid breaking the immersion of your player, right? So these games have a lot of graphics requirements, right? If we go down a little bit, we can get to a top-down 3D tool-style tower defense, right? Think Zelda the Wind Waker style of graphics, right? So here, what you need is less realistic and more cartoonish, and probably you will rely on shaders to get these effects, right? You'll probably not have a lot of lighting since your camera is very static and looking at a fixed point in space, right? Perhaps you're going to use very customized, very specific post-processing effects, once again, to reach the cartoonish feel of your game, right? And of course, you're going to need some UI especially for menu and interaction with your units, etc. And if you go all the way to the bottom, you have a 2D puzzle game for low-end devices. You have, say, a chess game that you want it to run on a $50 Android phone. So this is a very bare bones game, right? This will only use sprites. This is not going to use lighting. No post-processing effects at all, right? Maybe some particles and a lot of UI and text. So you see how the requirements, the graphic requirements of this project vary wildly, right? And this is one of the reasons why Unity is integrating SRPs into it. SRPs are all about customization, transparency. It's all about giving you the ability to process the graphics of your game exactly the way you need it, right? Make it as clear for you as possible. So this is what SRPs are all about. Now, let's talk about the scriptable render pipelines that are available at Unity 2018.1, which, if you're not aware, has just been released. So it is live, finally. Okay, so first of all, we have the built-in render pipeline that is the rendering pipeline that you know and hopefully that you love, right? It is the way that Unity have been doing things up until today. Now, in terms of the scriptable render pipelines, we are offering 2 versions of them for you. So the first one is the lightweight render pipeline, LWRP for short. The second one is the high definition rendering pipeline, HDRP, once again for short. And of course, most importantly, we're delivering for you the ability to create your own pipelines. So let's go over into a little bit of detail into each one of those 3. So the built-in, the LWRP, and the HDRP. So as I said, the built-in is the existing rendering pipeline, right? You have a lot of options of shaders, of post-processing effects. You have rendering options. This is basically the rendering pipeline that was used for Adam and the blacksmith. Of course, this, as you may know, work well, right? It covers a lot of cases, but it has downsides. This pipeline is a black box, right? It is not very clear what happens into it unless you are a very, very advanced Unity user, right? And of course, it may be overkill in some cases. Once again, for your 2D puzzle game to run on the $50 Android phone, you don't need all these options, right? It's good that Unity offers them to you, but maybe you don't need them. One other detail, and is one of the reasons that we are offering SRPs to you, is that there are cases of companies that use Unity and customize the rendering pipeline, the current existing rendering pipeline, to cater their needs, right? The problem with this approach today is when Unity releases a new version, this customized built-in render pipeline may not be compatible with newer versions. So it would require extra job to make it compatible with newer versions, right? And as I said, this is one of the reasons behind releasing the SRPs. Right? So, jumping into the LWRP, the lightweight rendering pipeline. First of all, the screenshot you are seeing on the right side of this slide. This is a project being developed by an internal team within Unity, exclusively using the LWRP, right? Just so you have an idea that even though it is a lightweight rendering pipeline, doesn't mean that you can create very good looking stuff with it. So the LWRP is all about performance, right? It is a rendering pipeline for mobile devices and for XR that require a lot of graphics performance as well, due to the need to render each frame twice. Of course, it does have its limitations, right? It does have a slight advantage, which is the single pass forward rendering, which allows you to render up to 8 pixel lights in a single pass, and you're going to see that in the demo in a second. But you don't have real-time GI, you don't have point light shadows, and point light shadows is not much of a trade-off because on mobiles, point light shadows are very expensive, so you wouldn't use them anyway. Of course, PPS, post-processing, is very limited as well. You don't have light cookies, and so on and so forth. But it does, the LWRP does have its advantages. It includes a lot of compatible standard shaders, including a tool to upgrade Unity standard shader to LWRP shaders, right? And you can use shader graph generated shaders with LWRP as well. So that is pretty cool. Jumping into HDRP. If you guys were here at the keynote yesterday, you have seen the Book of the Dead. And Book of the Dead is a fine example of HDRP in action, right? And as the name implies, HDRP is targeted towards high-end PCs and consoles, right? And you have, as you can see here, so this is the material configuration for the high-definition render pipeline. And you can see it is exposing to you a vast amount of configurations, much more than what the standard shader offers to you today. And the standard shader does offer you a lot of customization, right? And the HDRP offers you even more, right? So let us jump into the Unity editor so I can show to you how the rendering pipelines work. So I have here a little project, which is a scene that have a robot walking, and as you can see, this robot have a light on it, and this light is illuminating several objects in the scene, and these objects are casting shadows. So for instance, now the robot is pointing to the chairs, and you could see the real-time shadows of the chairs in the wall. In front of this tunnel on the left, you also have a light that is casting real-time shadows on that pole in front of the entrance and on the robot as well, right? Also, you have a couple of lights here, the corridor behind, let me try to point to you, behind here the chairs, and those are also casting a shadow from the robot, right? Also on this scene, we have a little bit of post-processing effects. Let's have a look at what we have in terms of post-processing effects. So we have bloom, ambient occlusion, color grading, grain, and vignette, right? So this scene have, despite being static, despite being very simple, there is a lot of things going on. And if you look at statistics of this scene, you can see that we have over 1,000 batches, 1 million triangles, and 1 million vertices. So that is a pretty hefty scene in terms of graphics, right? And most of them are because of lights. So if I select all my lights in my scene and I simply disable them, you can see that my batches, my triangles, and my vertices fall to half of what they were. But of course, I don't want to disable lighting in my scene, right? I want to use lighting in my scene. I want, otherwise it's a very, very dark game. So here's where I'm going to get started using the LWRP. And how do you use the LWRP in your game? There is a very easy way, which is by installing it using our package manager. So if I click here on Window, I have an option here called Package Manager. And if I click on Package Manager, I have the list of packages that are currently installed in my projects. So I have ads, analytics, IAP, standard events, and I also have render-pipelines.lite, so which is our LWRP. Now the cool thing about the package manager is that it allows you to easily install and control the packages that you have on your game, right? For instance, I am using right now the LWRP version 1.0.0, but if I go to the right side of my package manager window, I can see that there is a new version, 1.1.5, that is already available, and I can update immediately into my project, right? And of course, I also have here a button called All, which will show me all the other packages that are available to install on my project, right? And over here, I have render-pipelines.high, which is the HDRP, right? So I could, if I would use the HDRP in this project, I could easily install it from the package manager. So this is how you get started using SRPs. Well, more specifically, the LWRP and the HDRP in your project. So, since I already have the LWRP installed on my project, I don't need to install it again. What I'm going to do is I'm going to go to my Project tab, click on Create, and I have an option here that says Rendering, and inside Rendering, I have the Lightweight Pipeline Asset. So when I click on Lightweight Pipeline Asset, I create a new object. Let's call it so LWRP. There you go. So in this lightweight rendering pipeline, I have, as it would be expected, a very limited number of options to customize my game, right? And they're going to go over a few of them in a second. But now, I am ready to start using the LWRP on my scene. It is super simple, as you have seen, right? Just click Create, Lightweight Pipeline Asset, and that's it. And how do I enable the LWRP on my game? I just go on Edit, Project Settings, Graphics, and now here, on my graphics settings, I have this option, Scriptable Render Pipeline Assets. And all I need to do is drag this LWRP I just created, and done. Now my game is all pink. It's all, well, magenta, really. Now my game is all magenta, and since it is all magenta, it's going to render very, very fast, right? Well, what happened here? What is going on, right? If I select an object here, any object at all, so let's say here, I can see that this object here have several materials that are using the standard shader, right? And the standard shader itself is not compatible with LWRP. But as I said, when you install the lightweight render pipeline, a set of versions of the standard shader that are compatible with LWRP are also installed. So all I need to do is click here on the shader, and you have an option here that says lightweight pipeline. And over here you have several versions of the standard shader that are compatible with LWRP. So if I select this material here, and I select my standard, my lightweight version of the standard shader, you can see that now my object is being correctly rendered, right? But I mean, it would be difficult. It would be a very effort task to manually change every single shader in my scene, right? I have several objects here. It will take me forever to set all of them. So that's why when you install the LWRP, you also have an option here on Edit, Render Pipeline, and you have here an option, Upgrade Project Materials to Lightweight Materials. So all I need to do is click here, and there you go. Now, all my scene is reconfigured to use the lightweight version of the standard shader, right? One detail I forgot to mention is that when everything was magenta, the Unity logo, this holographic Unity logo we have here, it is. So this logo, despite everything being magenta, this logo was being rendered correctly. And that's because this logo was not using the standard shader. It was using a different shader that was already compatible with the LWRP, right? But now, our game, by simply enabling the LWRP, went from 1 million batches to 441, from 1 million triangles to 370,000, and from 1 million vertices to 400,000 vertices. So you have here over 50% increase, 50% decrease in the demands of batching vertices and triangles, right? There is, however, a slight issue now with my project. So if I run my scene, you can see here, especially pay attention to the pole here. You see that you had a shadow that blinked on, then blinked off, and then it was replaced by the shadow from the light that is in front of the robot, right? So it had this weird, very strange behavior. And why is that? Remember that when I was talking about the benefits of the lightweight render pipeline, the benefits and the trade-offs, I mentioned that you can only have one real-time shadow source per scene, right? So what's happening here is that this pole, the shadow generated by this pole is alternating between a light that is on the entrance of the tunnel, I'm going to show you in a second, and the light in front of the robot. So that's why there is this switch, right? It is based on several criteria like distance and angle. So it keeps alternating between the two, right? It gets confused, so to speak. So how can you fix that? It is super easy. If I go here, so this light right here that I selected is the light that is right in front of the tunnel, right? If I turn it off, you can see that. That is the light. So all I need to do is, in the light configuration, you have this render mode, and I'm going to set the render mode to important. So now when it comes to casting the shadows, this light have precedence over every other light in the scene. So now, if I run my game again, you'll see that now the shadow of the pole is fixed. See? The robot, the light in the robot is no longer casting a shadow on the pole, as you can see, because the shadow is being cast by that light that's right in front of the tunnel, right? And of course, as I mentioned, you can only have one source of shadows. So if you pay close attention, the robot, when the light shines on the chairs, it is no longer casting a shadow on the wall. The same way this blue light on top of the Unity hologram no longer casts a shadow of the robot on the floor, right? So the only light casting shadows is the light in front of the tunnel. So that is, as I said, one of the trade-offs of using the LWRP, right? But you also saw the benefits in terms of performance. You have less than half of patches, triangles, and vertices thanks to the lightweight render pipeline. One other cool thing, as I said, the LWRP allows you to have up to 8 pixel lights on a single pass. So we can see it here. If I go and select my LWRP configurations, one of the configurations is the pixel lights, which is now set to 4. And I can change this configuration with the slider, so I can go from 0 all the way up to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Done. So let's have a look at the number of batches when I change the number of pixel lights. Let's start with 0. So when I have 0 lights, you have 410 batches. When I jump from 0 to 1, I go to 479. When I jump from 1 to 2, I still have 479. So now, no matter how many lights I have, up to 8, the number of batches will remain the same, right? We didn't have an increase in number of batches because of an increase in number of lights. So this is, once again, one of the benefits of using the LWRP. Great. So now let us switch to the high definition render pipeline, the HDRP. And I want to show you a few of the features that you have here that are available, right? So I have here a different scene, and what I'm going to do here is first I'm going to create a light. And it's going to move here so we can better see it. Put it near the floor. Oh, we are pretty far away from the floor. There you go. I'm going to change the color. Let's put some nice green. Okay. And as you can see here, you have, once again, on the HDRP, you have a whole lot more of configurations and options for your light that, the high definition render pipeline brings to you. So for instance, I have some different types of lights, different types of lights. So I have, for example, the rectangle light that it generates a rectangular shaped light. Let's just reduce the lumens here so it looks better. So now, you have a rectangular shaped light that you can use. And of course, this is a real-time light, so it's affecting, everything on the scene. If I point it to the buckets here in the back, I think shadows are disabled. Yeah. Oh. Okay. Let's load the scene again. There you go. Let's create the light again. Point light. Let's move it closer to the ground. So other than the rectangular light, you also have a line-shaped light. So let's do it like this. There. So the line-shaped light allows you to just reduce the intensity here so it symbols more of a line. Oh, I just set the lumen to 0. Let's put it back to, there you go. So as you can see, you now have a light-shaped line, which I can increase in length and give it a nice glowy effect on the shape of a light. That's pretty cool. You also have decals. So these two images here on the wall are decals. And I have one, oh my God. So I have one of the Korean flag, and the second one also have a normal map. So it's not just a blind image that I'm drawing in the wall. I also have a normal map, which is a very delicate normal map, but it is there. So let me open it so you guys can check it out. So here, so this is the normal map of the image that we are using as a decal. And of course, as a decal, I can, for instance, rotate it and have it applied on both the floor and the wall, right? Let's maybe increase the size a little bit. There you go. And as you can see, since it is a decal, it is also being applied in the bucket of paint, right? If I move it towards the wood, it is also being applied on the wood. It is, you know, a proper decal. So having a look, also, let me just unrotate this so it doesn't look stretched. There you go. So if I go here on my workbench, I have this helmet here. And if I have a closer look at the material configuration of my helmet, you can see, once again, the different configuration options that you have for this material compared with using the standard shader in the built-in render pipeline. Once again, the HDRP offers you a vast amount of customization options, right? And finally, one of the coolest things about the HDRP is the debug window. So if I go to Window and Render Pipeline, I have here a debug window option, which allows me to enable and disable graphics settings on my scene. And the cool thing about the debug window is that it runs on devices. So you change settings in the debug window, and you can see the effects on a device, not only in the editor. So for instance, let's zoom out here. So let's say that one of the options here that I have in the debug, you can see you have a whole lot of options in the debug window, right? There you go. If I say, for instance, disable shadows, I click on this checkbox here, and interesting. Okay, let's try enable opaque objects. So what's going on? Need to be running. Okay, great. Let me try opening the scene again. This is what you get first, the beta version. Great. Let's try opening. Then try opening the project again. Okay, well, while we'll open the project, just so we don't lose a lot of time, we'll jump back to the debug window in a second. So you also have, you know, besides the HDRP and the LWRP that you've seen, as I mentioned, the great advantage of the rendering of the SRPs is to allow you to create your own custom render pipelines, right? So we have a C# API exposed to you to allow you to create that, right? One of the examples is, as you see here at the right of the slide, is an example of a custom pipeline created by Keijiro Takahashi, who works for Unity Japan. So this is the retro 3D pipeline. So it draws the objects in a retro PlayStation 1 style of graphics. And the cool thing is that Keijiro made it available to everybody. It is on his GitHub page. You can just go there and download it and study it and use it, right? And I also recommend for you guys to check out the rest of Keijiro's content on GitHub, because Keijiro creates some very, very cool stuff to be used with Unity. So I highly recommend you guys check it out. So let me just see if my project has opened. And let's try this again. Oh, there you go. Now it's working. So let's get back to the debug window. And as you can see here, if I click on Enable Shadows, now that I've unchecked, I've disabled my shadows, you can see here in my game view that I no longer have the shadows. If I enable it again, and let's say I click on Enable Opaque Objects, and now you can see that I disabled the opaque objects in my game, and the only thing left is the lenses of a pair of safety goggles here. That's the only non-opaque object in my entire scene. There you go. So let's enable them again. So now you can see everything. Let's enable the shadows. And you can also work, instead of seeing, besides seeing the main camera debug, you can also have debug by materials. So let's say that I want to see the diffuse lighting bake on my scene, right? Exactly how it's going to look. You can see it in the game view. Or say, let's try something different here. The metallic setting of the object. So as you can see here, on my workbench, I have that saw that does have the metallic setting on a higher value than, say, 0, right? What else? Let's see if there's something else here. Base color. So you can see what's the base color of the object. You know, you have here several configurations to help you debug your rendering. And once again, all of these also work on the device that you may be running your game, be it a console, be it a PC, doesn't matter. You have it all available and working on the devices. So let's get back here to the PowerPoint to wrap it up and open for questions. So how can you get started working with SRPs, right? So, so there are basically 3 main ways. So first of all, even though you can install the SRPs via the package manager in your projects, we have made it available on GitHub as well. So you have the repo address here on the slide. And I've also added the Keijiro's GitHub repo for the retro 3D rendering pipeline. I highly recommend you guys to check it out. And the best way to get started is, getting the LWRP, getting the HDRP, tinker with it for a little, and check out all the stuff that you can customize. Well, as I said, the templates, the LWRP and the HDRP, are available in the package manager. Just download them and start working with them. And finally, we have recently made a blog post with a lot of comparisons between the HDRP and the LWRP, and with a little bit more details on how the SRP work. You can find it on tinyurl.com/HDRPUnity. Well, that's it. Thank you so much. This is my email, so j@unity3d.com. Feel free to reach me if you want to know more about Unity. Of course, we have the amazing Unity staff here in Korea as well. They're always available for you. I'm also at Connect, connect.com/u/j. I normally post some tips and ideas, mainly on 2D, which is the area I work more within Unity, but feel free to follow me, to connect with me on Connect. Well, and so with that, thank you very much, and I hope you enjoy the rest of Unite Korea, Unite Seoul. Thank you.